So my name is Amid. I'm the CTO and founder of Automate. Automate is an end-to-end consultancy company based in Israel. And this is a global meetup where I address more than one country and I share a little bit from my knowledge. The idea is to have an open conversation about this specific topic. So you're more than welcome to ask me questions so we can discuss, converse, and learn together. There's really no special agenda except having fun. So feel free to ask questions and tackle me. I'm here for you guys, okay? Great. So this is a follow-up conversation for the previous SQL session we had. We started around June talking about many subjects. One of them was SQL and BigQuery. And we provided an introduction to SQL. So if you're not familiar, the previous courses were uploaded to our community website. You can find them in this link. There's the video and the slides. But today's session, we're going to cover specifically SQLs in Join. I assume you have some basic knowledge in SQL. Am I correct?
Yes, you're correct. Some basic beginner knowledge.
Yes, this is a beginner course. Meetup, okay. So, allow me to begin. So a little bit about myself. I'm not the best in everything, but I really love what I do. So just keep challenging me, keep asking questions. The idea is for you to learn. In the past, everything was simple in terms of technology, but then came the big data and the cloud, and the inverse of the cloud, and everything became much complicated. So the solution is cloud methodologies and big data methodologies. This is, in my perspective, data engineering. And specifically today, we're going to cover SQL, which is a cornerstone for every data engineer. Just to give you a quick overview of the ecosystems, there's too many technologies everywhere you go, on AWS, on GCP, and it keeps growing. It's rather complicated. So in today's agenda, we're not going to cover a specific technology, but we're going to demo SQL query language on top of BigQuery to make things easy for us to practice. So today's basics. So let's start with the jargon. We have a couple of basic jargon which are important for this session. One is dimension and one is matrix. For every data project, for every query you're going to do, there's lots of dimension in the data. For example, of a dimension could be the date. You have a specific table that holds a list of dates. And the reason why you do that, because you want to compare the given data set to a dimension table to ensure there's no missing dates in the table. That would be a simple, naive explanation. And metrics are the calculation you perform per day. For example, in today's session, we're going to run some basic scoring stats per game, per user, and so on and so forth. Feel free to stop me and ask questions. Yeah. Is that clear? Okay. So joins. We're going to cover joins. Joins is specific syntax in SQL that allows us to connect two tables together into one new table that contains the information we just joined. There are several types of joins. We're going to cover the basics in terms of theory, and then we're going to do a quick demo on top of BigQuery. So, joins imagine a table that contains all the possible information is represented by this circle. And the other table, table B, is represented as another circle. The intersection of the two circles is called inner join, meaning the data that exists in both worlds. Questions, anyone?
I had a question, sorry.
Sure.
Okay, so maybe it seems so simple. So that's a very basic question. But if you don't mind, can you give us a very quick explanation of what jargon is? So I didn't get what is.
Jargon is the list of terms that are relevant to what we are going to talk about today. It's a professional term that implies there are a list of terms that are relevant for this discussion.
Okay, thank you so much.
You're welcome. Please feel free to ask any question. Don't be shy. Okay, so we discussed inner join, which is this one, but there are other types of joins. For example, a left join is a situation where you have the left table and the right table, and you only want to match data that is in the right table for this section that matches the left. Meaning, not only do you want the intersection, but you want also data on the left table. So everything on the left and the intersection of the right. Is this concept clear?
Yes.
So yes, it's clear, but what is this then the advantage of left if it's only the left table?
It's not only the left. You took a part of the right. It's a bit confusing. Allow me to do something maybe that will clarify. Okay, thank you for your comment. You see that the right circle has an overlap with the blue one.
Mm-hmm.
So you see it in a moment in the join. It's like this is the glue that holds everything together that exists in both tables. But you also want the values that do not match the right one. Okay.
Okay.
So we'll do a demo. Maybe it will clarify. It will clarify
great.
decision.
Probably later a bit more understandable.
Okay, so feel free to ask a question if it's not clear once we demo. Okay.
Great, thank you.
A right join is the other way around. It's something like a left join, but on the right table. So we take the inner join and what we have from the right table and put it in one table. And a full outer join is simply everything combined, even if there is a match and not a match. For example, union, a union of two data sets. So, having said that, just imagine that full outer join is exactly left and the right. Maybe it will be simpler. Whereas inner join is the combined result, the intersection between whatever exists here and here. Okay?
Okay.
So let's do a quick demo. Maybe it will be easier. Okay?
Sure, thank you.
Most welcome. So what you see here is a console for GCP Cloud, more specifically, a database called BigQuery. I've created a specific project for this meetup. We created 3 tables: fact, raw data, dim users, and dim games. Dim is a shorthand for or abbreviation for dimension. In fact, implies this is a history of all the operations that happened in the applications. So let's start with this one. And let's query everything. Oh, let's take the top 10, 1,000 rows. So you have a date, and for each date you have a session ID. It's just a generic number that represents a window of time that a user ID played in a game got this specific core. It's a gaming scenario or a use case, if you will. So we have over time bunch of users that may have played more than once and may have played more than one game, had several types of scores. Is this base data or this fact raw data clear? Okay, so as you can see, the user ID is just a generic number, but there's no real username attached to it. We don't know who is user ID 446. It could be Irina, it could be Saeed, could be me. So we need some sort of a dimension table that holds correlation between user ID and game name. I think there's a bug here. 1 second, please. Allow me to fix that. Okay. So as you can see, we have a dimension table called dim users, where you have a correlation between a user ID number and a user name. Let's query the data. Let's see how it looks like. So you see user ID 707 is my username 707. We made it simple for the purposes of demo, but this could be replaced with a real name. This is a synthetic data set created just for the purpose of this example to avoid breaking confidentiality of privacy of users, of real life users. And we have the same thing for games. For example, game ID and game name. So as you can see, there's not a lot of games in the system. There are 5 games. Naturally, we can generate game, my game 0, and so on and so forth. So we have 3 tables, and now we're going to apply joins to see what happens. Okay?
Sure.
So let's start with the basic table. We have here this one. We have the raw data. Okay, so let's bring that with data as this is 1, and we need the dimension data. The users as select store from. Let's take this one. And now that we have the data set, remove this. We can join them together in the following syntax. Select everything from data and dim users. Okay. Let's start with an inner join. Inner join. Let's call it, let's leave it at this. On data dot user ID equals. 1 second, please, guys. Sorry for the disturbance. And dim users equals user ID. What do you expect the result would be? Anyone care to guess? No? Okay, so let's run it. So what you see here is essentially the same table we had before called fact row data. Fact row data, yes, which consisted of date, session, user ID, game ID, and score, but didn't have username. Now we have a new table that consists with the column username from dim users. Mind you, forget that for a second. Dim users look like this, user ID and a username. So essentially, now we have both data sets or both tables combined. What would happen if I filter the dimension table to user ID 1 or 707, which we discussed earlier? What will happen to the amount of rows here? Anyone care to guess?
Only one record.
Only one record, exactly. Or all the records that user 707 has performed, which is 17. We didn't know that until we ran, didn't we? But now we know user ID
Have played 17 times.
Has played 17 times over time. Yes? Notice the dates are mock-up dates, so don't be surprised with future dates. Okay, so it makes sense? Okay. But what happens if I want to tell you, listen, I know you don't have a lot of users with their username because you have only one, user 707, and you know his name. For the rest, you don't have data on it. But give me all the fact data of all the users, wherever you have a match, for example, on user 707, show me the match. What would you change in the query? Anyone care to guess?
Is that null?
Try to
something
guess
like
and
that.
put it- Sorry?
Something with null. It's not.
Okay.
You want a distinct username, or you just want where you have any value?
Any
Any
I don't
value.
know. I don't know. Maybe it will change over time and I'll have new users. For now, all I know, I have a bunch of users. I don't know their name. And someone asks me to bring an enriched table of the raw data with the usernames. So what would you change in the query? You have the entire data set of 13,000 rows. And wherever you have a username, just add the username. Hint, the answer would be in today's topic. For example, it's either in a join, or left, or right, or a full outer. Anyone? Okay, so let's try together. I would like to add here left join, which is the same as left outer join. It's the same thing. When I press run, what will happen is exactly what we wanted. All the username which we didn't have a username will get a null. The one we did have information on, that's assigned their true name. So we got the original 13,000 rows with some enriched data. Does this make sense? Questions about this, guys, before we proceed? Okay.
Can you scroll up a little bit, please?
Scroll up, yes. What?
So you filter just user ID to get username. Anything else
No.
is left out.
I filtered from the entire data sets.
Yes.
Just one user ID to ensure I only get one match. See, one. If I remove it,
I
get all the users back. So let's go back to my query and ask. So we did that just for the sake of purpose of training. You don't really have to do these two steps. Yes? Okay. So once we did the left, we got this situation. So question, what would happen if I press right join? So essentially in this case, yes, Irena, please.
Yeah, you would get all the names, all usernames, not just,
oh,
it's just a 707. Oh, okay.
Yeah. But why do we need a right join? In case we have a username which hasn't played. For example, here we see 707, which we have a username. But what will happen if I will do the following? Union all Wait, dim users. And let's do details and let's edit the query. This is quick tricks by me. Union all 999 for, let's call it user ID, and 1, 2, 3, 4, 5, and Omid as the username. Select this as username, and this is as username ID. Can we run this? Seems like we can. So we should be able to get order. Let's do order by user ID, descending. So we can see the user was properly added. As you can see, here's my name. But we know I didn't play because I just added me. Let's save this view. Okay. And go back. Not to this one. Not to this one. Not to this one. Not to this one. And not to this one. And not to this one. Okay, here's our query. Nope. Where's my history? What? So let's do that again. One second. Just annoys me. I can't find it. What do we have here? History. Yay. So we have this query, opening a new query here. Okay, so we did that, and we did that. No, we don't want that. We want this one. Opa. Oi. Okay. So we want our query back. And now, what would you imagine would happen if we use the right join syntax? So let's run it and see. So we get all the user names for user 707. We have to remove this because we want all the users. What happened here? The users. So we got all the users back. So, but we should have order by user ID. Understanding we should have a user that can play. Didn't we keep the information? Let's see what happened here. We save this. We didn't save it probably. Bada, 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 bada. One second, allow me to fix the dim users. Yes, edit code. This was it. So what seems to be the problem? Let's see. Okay, if we select everything, order by user ID descending, we should have omit here, right? Yes, we do. So when we are back here, we're asking for all the users in all the data. We match it by user ID. I'm not seeing my user, but apparently it didn't match it. So it created, instead of a user ID, a null value. Do you understand what happened here? So allow me to be clear. We took this one as the left table, which contains all the information. So we have $13,150 rows. And then we took team users, which all the users played games except my user. And then we said on a write down, please give me all the users that have a match on your raw data and those who don't have a match based on user ID. But we never asked for the user ID on the right side. So we didn't get it. So we could ask for it specifically. What happens if I do this? What do you think the user ID would be? One second. Sorry about that. So I just added user ID and I called it user ID right table. So it will be a little bit clearer. And you can see going to the end of the that since no row in the row table contained user ID 1, 2, 3, 4, 5, there was no match. So essentially, this is a right join. This is why you use a right join to bring all the information from the right-hand side that does not exist on the left-hand side. Questions about this, guys? Okay, so full auto join would be the same. Bring me all the results from both sides, whether there is a match or there isn't. But we know, except for one user ID that didn't have games, all the rest have played. If we will add another row here on this table, factor row, which doesn't have redeem users this specific ID, then we won't have a match. We will have either null values on the left-hand side, or values on the left, but nulls on the right-hand side. Is this clear, guys? Let's see if there's a question. Yes, the recording will be available for you later if you RSVPs for the meetup. I will send it to you. So allow me to share one final few more slides and then finish this session. And now that we cover joins, essentially the idea behind this, can you see my slides?
Yes.
Thank you. Is to build an architecture and a data model that allow you to quickly and efficiently analyze data. We're not going to cover the basics of architecture today, but you should know that given enough data, you want to be able to sort it in an organization in a manner that will allow analysts to work with data. And the idea is to ingest data into your data lake, transform it. There are many types of transformation, but imagine a world where you want to clean your data and apply minor corrections to your data. And then the modeling layer would contain joins and aggregations, which we cover in the previous sessions. To summarize, everything we do has impact in terms of performance, cost, and simplicity. So whether or not we are aware, every query we run takes time. Whether or not it's fast, entirely up to you. How much data are you consuming, and how fast is your technology, and how good is your data model. And about the cost, it really depends from database to database. In some databases, it will be expensive to write queries, and in some it will be cheaper, depending on the use case. Yeah, but at the end of the day, it's your responsibility, or as an analyst, or a BI developer, or data engineer, or data scientist, to write a simple SQL, make it clear for the next one that comes. Essentially, data engineering, it's all about faster, cheaper, and simpler. You're more than welcome to attend our community website, which contains all the past information, blogs, movies, videos, slides about everything, including the previous session about SQL for more basic commands. You're more than welcome to use our YouTube channel, which contains all the videos. You can simply subscribe can help us grow our community. There's no commercial value here, even though I'm a consultant fee. This is something I do for fun, to help the community to engage. There's no real profit behind it. You're more than welcome to contact me. Here's my phone, here's my linking. Feel free to add me. And here are other groups and other YouTube channels we use, which are more technical. Any questions before we wrap up, guys? Thank you, Elena. Going once? Don't be shy, guys and girls. Please ask questions.
Not questions, but just thank you for presentation and preparing the data set. And this presentation was really fun. So it's not very clear, everything clear to me, but I have to practice. So thank you for this introductory part. Yeah, for learning.
You're most welcome. If you want, the previous session was a bit more about BigQuery, more technical, how to use this database we just used. So you can use that it was demonstrated in previous sessions. You can open your own GCP account for free and get $300 to experiment. You don't need more than a few cents. It's very cheap. I specifically selected something that will be simple to use, highly documented, very easy to get started, and you get credits by Google just simply to learn and educate yourself. So another way to use that, if you feel like it was a bit too much in terms of technology, you can go to W3 School, and there's SQL tutorials there. SQL, not S3. Sorry, I was confused. And you can start learning, and you have all the information that explained in detail on the left-hand side. For example, what we discussed here, right joins, and you can even run data and see what happens. You can try it yourself. Okay, you can run the query and you'll get real data. This is very helpful.
Great, thank you for that information.
Good. So it was a pleasure to meet you all. I hope we meet again in the future in other topics. Thank you for your time. Have a good day.